Hi, I want to look at problem number 1 on the WebAssign from 4.1 and apologize because sometimes I look at just the answers and decide, oh, that answer looks nice, it doesn't look too messy, and therefore the problem will also be nice. And that has backfired on me a couple times this year. So normally I try to do the assignments ahead of time, and with arc length I felt good enough, I was like, oh, we're not going to do this. I regret my choice. So I'm going to apologize to you on number 1, and I want to show you what it looks like. So we have this arc length formula here, and we know normally what we would do is we would set up a integral. Well, first we'd find the derivative. And in finding this derivative, we would get 1 over 2 times the square root of 2 minus x squared times the chain of negative 2x. And therefore, simplified, this derivative would be negative x over the square root of 2 minus x squared. Okay, and we know what we're going to do to find the arc length, and that is we are going to take the integral from 0 to 1, they gave us the bounds, of the square root of 1 plus this loveliness squared. So negative x over the square root of 2 minus x squared. Now let's simplify this just a little bit. And if we simplify this just a little bit, we get 1 plus x squared over 2 minus x squared. Now, the way that we want to go about this at this point is we are going to simplify as much as we can by making one fraction for what's underneath the radical. I lost my dx. So we'd get 2 minus x squared over 2 minus x squared plus x squared over 2 minus x squared. Simplifying that, we would get 2 over 2 minus x squared, all under the square root. And now, what we would do now is we would go and I would probably, actually, let me think through this. I would probably pull out a radical 2. So it leaves me with 1 over the square root of 2 minus x squared. Do you feel good with that so far? And now comes the slightly tricky part. We have not really talked about this particular antiderivative. Oops, bound 0 to 1 dx. Let's get my notation in there. We've not really talked about this particular antiderivative. But we have our trig functions that have integrals that are special. And one of them is the arc sine, or the sine inverse. And the sine inverse, sorry, I've got something in my throat. The sine inverse looks like this. It says that, I'm going to write it up here, which means I can't move this anymore. So it says the arc sine of x, or the sine inverse of x, is equal to the integral from 0 to z of 1 over the square root of 1 minus z squared dz. Okay, now what does that look like for us? Well, when we go to take the antiderivative of this, when we go to take this antiderivative, I'm actually going to, let's rewrite it one more time. Let's do root 2, the integral from 0 to 1, because remember we want it to be with those bounds, and I'm going to put it as 1 over the square root of, and then I'm going to write this as the square root of 2 squared, which is just 2, minus x squared. So when we go to take the antiderivative of this antiderivative is the arc sine of x over root 2, evaluated from 0 to 1. And when we substitute this in, I'm just going to leave that root 2 out, The arc sine means the sine inverse. It means the angle that gives us that sine. So really what I'm doing is root 2 times the arc sine of 1 over root 2 minus the arc sine of 0. Another way you may see this written is the sine inverse of 1 over root 2 and the sine inverse of 0. Okay, and so this would be root 2, and the sine inverse of 1 over root 2 would be pi over 4. And the sine inverse of 0, or the angle that gives us a sine of 0, is 0. And so that would look like that. And therefore, the length of this arc would be root 2 times pi over 4. Now, it was mentioned to note that the curve is part of a circle. And if you were to graph y equals the square root of 2 minus x squared on your graphing calculator, what you would see is that's an eighth of a circle that has a radius of root 2. And so an eighth of a circle with a radius of root 2, if you were to do the circumference of that, it would give you the same thing. So sorry about that antiderivative there that we haven't actually worked on. I'll do the problems, duly noted. Thanks, guys.